Well, thank you very much indeed. And the speaker before me was asking two questions. I have just wanted to start with, who's the first time here at the conference? Oh, that's great. That's really great. Well, I have a second question as well. Who considers himself sort of like a novice to GeoPython or hasn't done so much? And yeah, because what I'm going to talk about is for those. So the two of you can stay and the others are free to leave. However, when I handed in my presentation, I thought, well, after all these years, I assume that there's still people coming on to this issue, to this topic. And it might be maybe some kind of like a good idea to give them kind of like an overview, what is behind the term GeoPython. And I don't mean to do that in a concluding way, but just some bits and pieces that I came across over the years. And I mean, listening to some of the presentations, I really got lost because it's too technical for me. However, so what I'm going to speak about within the next few minutes is what you can see, hopefully can see and read at the back is, so I will show how, for instance, to geocode, compute some isochrones, visualize both the centers of the isochrones and the isochrones themselves, how to access an API with the example of earthquakes that has some spatial sort of like dimension, and then also how to download OSM data and do a little bit of computation, etc. And yeah, basically do also some routing based on OSMNX, which is also a module, just to kind of like give you, as I said, a little bit of a taste what can all be done. And I hope that everything is running smoothly because it's just live. So first of all, as you can see, I have a couple of modules that I import, etc. And then I indeed, for doing the geocoding and also some other stuff, I had to apply for some API keys, which I don't show here because they're my personal ones. And I load them, and I just created a little method to run an API command. And then I have here a couple of cities. I just, for the time's sake and the performance sake, I just went for those four, for Basel, Zurich, Alton, and Bern. I also tried it with many more, but then it just takes too slow and I don't have any good jokes to tell during the computation time. So this is what I do now. I just run that. I can geocode those cities, and as you can see, I get back the coordinates from this API. I put that into a data frame, populated, and as you can see, it's now a geospatial data frame, so to speak, with some geometry. I do have to set the spatial reference system, and then I do a simple plot, which is not very attractive, but however, I can tell, yeah, that looks fair enough. This is Basel, Alton, Zurich, and Bern. Of course, any other context is missing, so it doesn't really help you if you're not familiar with the area, however. And again here, the GeoPandas data frame, excuse me, also with all the information that you can process and do whatever you want with it. So now, next step is to use those four cities and compute some isochrones. So isochrones are basically just geometries that, based on a root network, have from a center an equal distance. And there's, of course, many different distance concepts. You could use the time, you could use the distance, You could use a Manhattan distance or whatever, or a topographic distance, etc., etc. I'm just going for a topographic one or topological one rather. And as you can see, I have different drive times here. And I do those, all those different drive times for each city, and then store the results, what I get back from the API. It's, as you can see, here is the API URL that I call, and let's just run that. It takes a while, not too much time, but it will come, I promise. I hope. So we're done now, and as you can see, these are just the last few bits and pieces of the data I got back. 24 isochrones I computed, so for 6 drive times, 4 cities, and I have here my my range basically, just so the input time that I used, and I have here the geometry that I can use for further processing. So I store that basically, which is another thing that you might want to do in a geopackage file. For instance, if you want to take it out, go further with it in QGIS or any place that you prefer. And again, I can have a look at it. So not very attractive, but it shows you basically just the polygon that were computed. Again, you can make out the 4 centers and the area basically that was computed. A slightly nicer plot is here with a little bit more of a color, and you can make out more like the zones with the shorter drive time compared to the ones with the larger drive time. And of course, it would be much nicer to have it as an interactive map where you can zoom in, etc. So I think you've seen that yesterday and today already many times. So it's not something very new that I'm presenting. But again, it's something that is available and can fairly quickly be done, also with some information like that. So the next thing that I'm showing is going through an API and download some data on earthquakes and visualize that as well. Also do some kind of like a thematic map where you can see basically I have many sort of like parameters that I send. So I sent the API the bounding box basically, and also some threshold of magnitude that should be taken into consideration, and of course starting and end time. So in which time frame the results should be fetched and retrieved. And then again, a little bit of Python, and then I color code it based on the magnitude. So I can click on it and then I can see, 2.5 magnitude, etc., with a little bit of a description that comes back from the API about the location, the information, and also when it was registered. So that was in 2004. Another one here, for instance, is in 2008. Slightly larger one, etc., etc. So easy task, maybe useful if you have any other API that you know and want to get the data, display it, etc. Now going to OpenStreetmap, we've already had a talk this afternoon about that, and downloading some information like cafes in Switzerland. Again, displaying them. See what it looks like as tabular data. And then adding this to my existing map. So as you can see, I have my cities, I have the isozones, and I do also have now, unfortunately in the same color, my cafes. And what I can do now is do some spatial analysis, some maybe primitive spatial analysis, however, may be useful, just a little bit of a count. How many cafes are there within a specific isochrone, so that, for instance, I know where I live within, I don't know, 15 minutes, I have a decent choice to make or not, whatever. Whatever it is, then instead of cafes that you want to basically analyze or use, etc. So again here, I have the count. I could use that for further statistics or whatever. And keep going. And we've seen that also before, some kind of like a choropleth map based on the count of the number of cafes, the isozones also labeled, etc. So you can see Basel is a lot more fortunate when it comes with serving than maybe Alton, but of course Zurich beats it all, etc. I think Bern is not as fancy. Yeah, exactly. And now moving on to rather something more analytic in terms of like routing. I also can do a routing network with the data. And as you can see, this is some simple representation of nodes and edges of a street network from Basel. This is the River Rhine, and these are the populated areas. And then I can, for instance, do a simple computation of a route, give me the best way from one address to another one, and display it. Could be a service that you run, that you want to do, or just for fun, etc. It's all feasible just with a few lines of code. I think that's nice. I also did some kind of like computing, which just 5 minutes before didn't work anymore. So I don't know whether it'll work or not. However, what I did here is I'm basically just computing 10,000 random routes. And on the one hand, I use just one kernel. I think that's in this one. Yeah, you can say how many CPUs you're using, and if you apply none, then I have my full computational power, which is in this case it's 8, but for some reason I had this line of code in here, and then it was giving me out the time of your computation, but for some reason I don't know, it just before it. Anyone a solution why it doesn't work? I don't know. However, if it did, it would print out the duration. It is, however, a couple of times faster when I apply all my CPUs compared to just one. So you can also do some kind of like little benchmarking here. This is basically just what I wanted to show. And then also you can find out, especially with this random computation of the routes, I did 10,000. So this is basically what I tried, but not all were successful. For instance, if you managed to go downtown, you may have noticed that there's many just one-way lanes or roads. And this, of course, depending on which start and end point you randomly choose, doesn't give you a result getting from A to B. Might be possible to go from B to A, but not from A to B, due to some restrictions. And I can also extract the streets and the edges and the nodes, basically, if you need that. So download the network and get whatever you want to know. Also do some analysis on the type, for instance, of streets. With Seaborn, you can see there's most of them are of type residential, etc., etc. Some are unclassified. Yeah, just again a little bit of analysis with only a few lines of code. Then finally, turning towards the end, just giving a footprint of the buildings of the city of Basel. So these are, as I said, basically just the buildings. So extracting them, displaying them, giving some kind of, I think, like nice impression about the city, what it looks like, etc. Some kind of like a characteristic. I live around here, so I can even make out my own home. And if you happen, because the weather is nice, if you happen to go for a swim, the Rhine is clean enough. And around here are official places where you can go in. There's showers, etc., etc. Really nice area. Just if you happen, for instance, to stay for the weekend, etc. I think the weather is supposed to be nice. Going further, I extracted here, instead of having all the buildings, just for instance, the restaurants, the pubs, and the hotels. And of course, here you can see just only a couple of orange dots, which were filtered out of the data set that I downloaded. And again, if you are interested in the tabular data, you have it all here, all the information based from the download of OpenStreetmap. And finally, although I feel a little bit guilty because of what we were told this afternoon about water waste when using ChatGPT, but yeah, artificial intelligence is nearly omnipresent. So what I did just for fun this morning was I asked, give me the Python code that creates polygons in GeoJSON that have the shape of the letters thank you, and position them basically in the area of Europe with the special reference system of WGS84 and displayed in Folium. What I just wanted to show you is you don't have to really be smart anymore to write Python code, because it's all been done for you. And as you can see, that's the result. But be mindful, an N is not always an N. And a Y is not always a Y. Neither is a U. So we still need you to do the coding. And with this, I just close. Thank you very much.
Okay, thank you very much. We are a little ahead of schedule, but it doesn't really matter all that much because there's no talks upstairs right now. So we do have some time for questions if anyone has any.
Thank you very much for your great presentation and yeah, some kind of recipe how to proceed from here on. I'm wondering, what are you using GeoPython mostly in your day-to-day work, or is it a hobby? Because it seems like you have a lot of different things that you could use it for.
In all honesty, it's a mix of both, and where I work, I work for the government, so for the Federal Department of Defense, etc. I used to work for the Army until last autumn, and now I'm not directly working for the Army, but the Army is our only client within the administration, which leads me to the information that so much of the data that I'm supposed to work with is classified. In other words, I have a computer that I may not install some software on. So it's like I would use the comparison like you're a chef and I'm telling you, please cook me that great menu. You have all the ingredients, you have the recipes, you have everything that is there, except for the kitchen is closed. So this is how I feel. So I would love to do a lot more, but I may not. And this is why, and now I'm coming back to the answer of your question, it's more in my free time, yeah. Then and every now and again I just have an idea and then I just try to do it. I would love to do a lot more and with a lot more like application context where people really say that's useful. Does that answer your question?
Anyone else?
Thanks for the great presentation. I've never did any networking, like network analysis before. I have colleagues that do that. They use ArcGIS. And can you go a bit deeper on the basics on network analysis? Which library we use in Python, and is it efficient?
I'm not a specialist when it comes to that, but the things that for instance, what I find interesting is like availability of infrastructure. This is why I did the thing with the isozones. For instance, what about, and we've heard some interesting talks about this afternoon and this morning about energy provision. So where to install some energy infrastructure, etc., etc. And I think to have a most efficient investment in all these resources, I think needs such analysis of availability of what if some infrastructure fails, is it still resilient enough? Is it redundant enough, etc., etc.? So I can only say something about maybe what could be feasible approaches. But when it comes to performance, I think there's many other people here that might be more qualified to answer the question, what is most efficient, etc., etc. Both in terms of what modules, how to structure the data, etc., how to clean it. Yeah, I'm sorry about that.
Any other questions? I might just add a little to that one myself. I've done a little bit of network analysis. So the tools in Python are really easy to use for it. It works just fine. The issue that I had with it was more the availability of the data. And if you're pulling in things from OpenStreetmap, then if your area isn't complete, then that's where it runs into problems more than the Python tools. But to bring it back to what you're saying there, I'm one of the people who would be a bit newer to all of this. You know, I'm coming here mostly to learn rather than because I have great things to present. But I think that the tools that we have in Python and with QGIS as well is now kind of getting to the point where, as you said, it's really easy. Almost anyone can do it because all the code's already been written. And I'm sort of having the feeling that with the vast availability of geospatial data now, we're sort of getting to the point where this kind of stuff is worth learning the basics of for almost everyone. You don't have to be a full-time geographer, GIS, or geospatial professional to be worth having a little bit of knowledge of this stuff now, because it just can come in and be useful in so many areas. Would you agree with that, or what? Do you have any thoughts?
Absolutely. And I think the great advantage of that, and also for coming here, is when you start talking, you just create crazy ideas. But the crazy ideas finally turn into solutions. And you do things you would have never thought of just because maybe a keyword kind of like stuck with you. And again, I think it's mostly the people outside of a certain discipline that bring in the other perspectives and the different perspectives and the challenging perspectives. And this, I think, is why it's worth to have especially people who are not so much into the geo thing, because all we geos, we think the same, more or less. But all the others are asking, what's it for? You know? Yeah. And we then are challenged to find reasonable answers to those questions. And whereas they say, why don't you do that way? And you think, well, what's the purpose? And the person might explain, because that's useful for me. And sometimes, in all honesty, a little statistic like a min, a max, and an average or a mean is what they need. But to get to those data, you have to do a whole bunch of reasonable analysis first and clean the data so it looks like just a simple tabular information. And you think, well, that's just an Excel sheet, so what? But getting there is where I think we can contribute with our knowledge, with our approaches, with the way we see the world.
Yeah. I like that. Okay, any other questions? All right, well, thank you very much.
Thank you.